Thank you so much. Good afternoon. My name is Nguyen. I'm a COA and also the Fellow of Engineering Australia. So today I'm presenting the everything with the computer vision video intelligence system, which is unlocking the potential of deep learning in computer vision with unveil, which is our platform. So the agendas is talk about the first one. We talk about the issue with the video analytics, and then talk about the architecture. So actually that's the practical architecture, and then we provide the solution for the issue, and then going through step by step to create the AI model from start, and then design the AI task, and then integrate with LabVIEW application for the LabVIEW user, and how do we scale up, and then finally the third-party application integration in here. So when we talk about the typical manufacturing system, you see that normally we have something like similar to SCADA system. We have the main controller in here, which could be the main PLC or LabVIEW application or the other system. Underlie is we have the control system, could be the PLC or LabVIEW application, and then we do the control on production line. So we with the large scale manufacturing system, we should have a lot of production line. Then in that production line, we might have the vision system, right? So we can use the IP camera, GDevCon camera, or different type of the internet camera. And then recently, it's like a lot of manufacturing, they have the video management system. They want to put all of the surveillance camera in there, and then they want to do the quality control monitor thing. And this is in the past, but recently it's like we want to utilize the power of the artificial intelligence in there. We want to utilize the deep learning, machine learning in order to improve the quality control, or simply, for example, is want to define some kind of defect detection or see some kind of abnormality detection on that manufacturing. And the question is, how do we turn that normal camera or the GDevCon camera or the internet camera or the surveillance camera into the smart camera so that we can see what's going on without affecting the whole architecture? Yeah. So the idea is that we try to use the same architecture in here. And that's the question that I read about. And then if that's architecture, then there are a lot of subtasks in there. So for example, we have the MES system, and then the database, the reporting, and then VMS. So how do we turn that smart camera in and then connect to that existing system without changing the whole architecture, and then also send the result back into the database for further analytics? Right. So in order to do that, I come with one of the case study. So the case study in food and beverage is like design the defect detection system in order to reject the carton box using the existing surveillance camera. So in here, that's the same architecture that we use. We have those the IP camera, the surveillance camera, monitor the one of the production lines. So which is in that manufacturing system, we have so many different types of production line, but in here that we focus in one production line. And that one is have several kind of tasks. So the first one is we want to design the system so that is integrate with the main controller in here, which is written in PLC, very old one. So we don't want to rewrite the whole system. We want to add the value on that. And then we want to send the rejection system when we observe the surveillance system, see the defect, and then we send the signal into the live PLC on the certain one into do reject. And then we also want to send the alert system into the VMS, the whole thing. So the VMS will have the bookmark, and then they have the some kind of the alert pop up for the operator to see the thing. And then we want to see send all the defect detection event into the MES or database, so that they can see the whole thing and then find the root cause. So this is a quite typical application recently. So this is a system architecture that we propose. So the same system, but we add only 2 components in there. So the first one is like the unveil framework that we put in. So that unveil is running on the Windows server, so which is normally the VMS system is running on the Windows server. We can use the same server, so we can install the unveil. So when unveil install is like run as a service, I explain a bit later on. And then we utilize it's called the S device, which is the small computer with different type architecture. So could be the Intel, could be the ARM Cortex with the GPU in there, so that we can design the analytics on that and then outsource all of the AI inference in there. And then we also have some kind of the small plugin. It's called the unveil trigger service, run on top of the existing system. So in here, that's depend on different type system. We might not even need to have that system, the service. We can have some kind of standard protocol in order to connect to that system directly. So on the nutshell is this is a system architect. You see on the left-hand side we have the existing camera system. So normally all the company or customer have the existing camera. Either could be the IP camera, could be the onboard camera, and then they have the existing application. So the requirement is like we're not allowed to rewrite the whole architecture. We want to reuse that thing. And then what we going to bring is we bring the unveil, the framework. And then from the unveil, we have some kind of special tool. It's called training tool. And then try to utilize the existing technology, which is deep learning and machine learning. So the things that with the unveil, we be able to connect directly into the camera. So we have the some kind of special driver to connect to different types of camera with the surveillance and VMS technology. And then we collect all of the data using our training tool, which is like another tool set allow us to design any customized AI model with few drag and drop. And then when we have the model, we use unveil again and then deploy the model into the S device running as the standalone local inference engine, and then using some kind of the trigger in order to talk to the existing application. So which is the overview of the system, and then I walk you through how we use that, utilize that using the tools that we develop. So come back with the case study. So now what we have the surveillance camera, right? So we want to capture all the images and then form the database, the data set, and then using some kind of the tool that we design in order to do the labeling and then provide some kind of the AI training on that. Yeah. So this is the workflow. The workflow of designing any customized AI model is going through the first one is collect the data from live camera, and then we do the performance of the data labeling and then configure the AI model using the transfer learning technique. So we can offer all range of the technology from the object detection, segmentation, classification, something like that. Yeah. And then when we have the model training, and then we need to evaluate the model. So we need to make sure that the model is work well in the test environment with different types of test set. And then we verify that model and then export it before we can use to create the certain AI job. So there are 2 steps. The first one, we create the model, and then the second one is we use that model and deploy into the production. Right, so the first model is like here's the unveil. So unveil, we have the all sort of the driver allow us to connect to different type camera, even the surveillance camera. So we can connect directly to that camera and then capture the live image and then export it into the data set. So this is the first utility. And then when we have the image or with the data set, then we use another special tool. It's called the labeling tool. So we build that label in-house and then allow the user to label all of the defect or the special thing about the data, right? And then when we have the data with label, then the next step is we need to design a certain AI model. So in certain application, we try to do the object detection on that. to find some the carton box and then some kinds of defect in here. So we have some kinds of special tools called the ANSVIS Object Detection Studio with the graphical user interface for the user to load the data set and then specify the model in order to do the model training. So in here we can utilize between the local GPU engine with the NVIDIA, or we can utilize what we have, that's the cloud version of that, which is the user doesn't have the GPU resource. We can connect to our cloud in order to do the training. So after the training, we have the validation to see all of the parameter of the model, such as the accuracy and then the performance of the model on the test bed. Yeah. And when the model is been validated, then we export model in the special file. It's called zip file, and then we use that one upload back into the unveil again. And then from here we can start designing the special AI tasks, right? So the sum up that we collect to the custom data directly from the camera view, and then we design a certain model using the deep learning and machine learning technique using the tool without any kind of the Python code. And then the second step is like we need to design a certain AI task, which is again come back with the, for example, the defect detection with the carton box, right? So the workflow is we get the camera stream, and then we do the pre-processing. The pre-processing is like we use different type of technique in order to do the image enhancing, and then from that we can combine different type of AI model to form the AI model pipeline to do the inference. And after that, depend on different type of customer application, right? So we have the business customized business logic, where we design all the plugin for the user to form the business logic inside the framework, and then we also go into the post-processing and then trigger with the main controller. So again, come back to the previous application, we have the surveillance camera, and then it's looked into the production line of conveyor belt. So now we want to do the image capturing and then pre-processing. And after that, we utilize the models that we have trained. So on the model, then we need to do the custom logic on that, and then do some kind of the post-processing, whether we want to combine between the deep learning, machine learning technique with the computer vision, which is NI vision development. And then after that, we have three important triggers. So the first trigger is like we want to control the PLC, the PLC to do the rejection. And then the second one is we want to send the bookmark into the existing VMS system to do the popping, and then also save the data into the database so that they can do some kind of the report. So in order to do that, is the unveil have the way for the user to create the pipeline, what we call the deployment group. So when we start the deployment group, there are several steps to follow. The first one is like we select the camera where we want to add the intelligence on that, right? So this is a normal camera, and then now we have the capable of adding the AI model on top of that, so that it's become the smart camera. And then on that one, we can edit so that it's like the, now we have the camera stream. Now we want to do the pre-processing on that. So the pre-processing is like, we have some built-in pre-processing, but we build that one is on the plugin, so that the user can design their own pre-processing using NI vision development in here. So I'm talking about that with the plugin. And then after that, we can select the model, right? So in here, that you know that in the world of the AI, we can use different type of model, and then we can have some certain model to work together. Like the one model is the output of one model could be the input of the other model. So we call the model pipeline. All the two models can work in parallel. So in here, that we can build that the model can work together, and then in certain pathology, in here we use one model, and which is object detection in here. But it's not limit for the user to use multiple or different type model. Yeah. And then when we have the model, the camera stream, the pre-processing the model, now we want to do the custom logic. So again, the custom logic is like allow the user to define the, because normally the deep learning and machine learning is not magic tool, because you know that when we do the inference, then the outcome might not be what we after. Right? We need to do some more process or maybe analytics on after we have the inference, so which is the business logic. So we build in several different type of business logic in order to cover all of the range. For example, it's like the inclusion rule in here. So the first one, we need to detect the main object, which is the carton, and then we know that the defects could be around the carton. Then we have some kind of inclusive rule in here. Again, that's the business logic is like the plugin. So the user have the flexible to design their own business logic. And then after that, we have the post processing. Again, for example, if like when we have the result, then we want to do some kind of measurement, right? So which that measurement is like exists on the deep learning world. So we need to combine between the deep learning, machine learning with the existing computer vision technique. So in here that we have built in post processing, which is filtering. And then we have another one which with its NI vision post process, which is we can combine with the NI vision development tool in order to do some kind of post processing in here. And then after that, we configure the trigger. So like I said, it's like we build all of the typical protocol like the HTTP post, HTTP RESTful API, and then TCP/IP, and then few the other very standard protocol in order to talk to the third party. So in here that we build the HTTP post in order to send the reject signal directly into the PLC. So on the PLC, we have the small little program in order to handle that kind of the request. Again, with the configuration of trigger, we also need to can talk to the VMS and then database directly. So this is the procedure of configuring the AI task from beginning to the end. So from building model, and then from the creating the AI task on the ANSVIS in order to do the a certain job for that kind of the application. But the question is like on that manufacturing, we have more than one task. We have more than one camera, which is maybe scale up into 100 camera or 100 AI tasks. How do we handle that? So this section is before we're talking about the scale up. We're talking about the some kind of plugin allow us to integrate the LabVIEW application on that framework. So the customer with LabVIEW plugin is have two areas. The first one is pre-processing and then post-processing. So all of the pre-processing and post-processing in here, the user can design their own pre and post-processing using the NI vision development or the other tool. And all of that plugins we develop in the package library, which is maybe, and then we follow the certain template. So the user can take advantage of NI vision development module in here. So the procedure is very simple. When we build the pre and post processing on the file, or we have the special utility allow us to install that on the ANSVIS. So it can be the pre-processing or main processing or post-processing. So the main processing is like similar to NI AI inference. So if we don't want to use the deep learning and machine learning, we can bypass that one and then we install the main processing as the inference one. Yeah. So when we install, we can put all the parameter in there. And then you on the post-processing configuration that I already talked about. And the question is like, after we done that, how do we integrate that thing with the LabVIEW application? Because You know that the ANSVIS can be standalone application. It's running as a service. And then we outsource all of the AI inference and AI implementation on that. So now the user have existing LabVIEW application. We want to utilize that one and connect to the LabVIEW as a process. So we provide the LabVIEW integration in a very convenient way. So it's going directly through the TCP/IP integration, right? So that's ANSVIS trigger service. So we provide the API, and in order to integrate that, we select the trigger is like the application, and then specify the IP address and port on that, and then send all the data in binary, and then on LabVIEW application, we just follow the protocol and then handle that all of the trigger result. Yeah. All right, so come up with the previous step is like scale up. So now how do we do the same thing with the one production line with the 10 different production lines, maybe 100 camera, right? So we design the system is running all the parallel. You see that all of the things running on the parallel, and then only the thing is how do we add the result in? Right, so we have the main server. So one main server cannot do the inference for 100 AI tasks. So we solve that issue by introduce, it's called the edge computing. So this is edge device. So edge computing is like the small device with the small computer with the GPU. So the again the architecture could be the ARM Cortex or Intel, and then we simply add such one in, and then when it add in, we have some kind of special firmware allow us to flash that edge device into something like it's called discovery middleware, so that it can talk directly into the ANSVIS. So when it has the firmware, we can easily connect to the ANSVIS. So the beauty of that is all the model when we upload in, when we accept to that, we can go in directly to the edge device and then going to the result. For example, the camera in here. And we can download the model, the raw model, what we design in, and then the download is not only the download, it's also doing some kind of the special magic in there. It's do the model optimization or the model quantization, so that is compatible with that hardware. So we can get the performance of that. So the procedure is adding the AI task is similar to what we are talking about, but in this case, it's all the model running and then AI inference is running on the edge device. So you see that when we have more tasks, we simply add the edge device on, and then we can scale up from here. The final one is like the third-party integration. Like I said, is I walk through all of the built-in plugin, so that's the pre and post processing, and then the LabVIEW integration. But some user, they might have different type of the third-party application running in different service. Then we have two type of the integration. So the first one is like going through the trigger. So trigger is in here, which is like, for example, the VMS, database, hardware, MES, or third-party through the cloud. So in here, this is a plugin. We can provide the plugin, which is driver, so that the user can connect to existing application. But the second one is like when the user, for example, they also in the AI area, they design their own AI platform, and then they want to take advantage of the GUI and then the scale up. So this is a third-party AI platform. So we have it's called the OpenS API, which follows standard. And then the users just follow the API in order to design the inference and then send the result back so that we can handle that. Yeah. So here's an example that we allow the user LabVIEW developer to design the AI natively in LabVIEW. We provide all of the native API, which is we can take advantage of that, and then using the model that we train, and then we create something like the inference running independent from another computer, and then as the something like the S device, which is LabVIEW version, and then talk to the system in the way. Yeah. So when we design that, ANSVIS can talk to the third-party device through the OpenS API with a tick box, and then the procedure to design the AI task is exactly the same. So here, that's a few demo. So the first one is the production line when we try to do the product counting on the conveyor belt. That's got a very simple UI. This is the business logic. So the users only need to do some kind of configuration, which is like when the product going through that step line, then it's do the counting. And that one is like the some kind of quality check when we do the in the production, right? So find some kind of the missing, find some item is defect, and then send the report back into their MES. So all of that type of thing on the ANSVIS, we have the dashboard allow the user to see what actually in there, and also send the log, event log, which is we can easily search what's going on, and then we inspect the production line. Yeah, that's the event log. So it's a cookie inspection again. Yeah, quality control, and something like the procedure, right? So parts. So the operator do the assembly, and then we want to know whether they follow the procedure or not. Yeah, so that's kind of defect detection to find some kind of the defect on the electronic board. Yeah. Yeah, any question?
Are these actual employee systems you created?
Yep.
Yeah.
Yep.
Yeah.
So to sum up this, we provide the platform, right? So platform to simplify the machine learning, deep learning application for the LabVIEW user. We try to make things easier. So the reason when I design that thing is like, I start LabVIEW is like 6 years ago. It's not long. And then in the team, one of my senior saying that machine learning and deep learning is very powerful. There are a lot of framework out there, and then he want to create one of the application using the machine learning, the deep learning. So he try Cafe, he try TensorFlow, he try PyTorch, all of those things. But the first one he frustrated is like very difficult to make the environment work because it's work with the GPU, CUDA, all of the installation setup. And then with the low level deep learning and then Python, thing like that. So it took him 6 months without going anywhere. So it's motivated me to do something with simplify all the process. And then when I see on the NI community, it doesn't have any machine learning, deep learning toolkit there. Only one is called NTOS, which is very low level, and then we have to do everything from ourselves, right? So on block diagram, and that toolkit doesn't provide us the latest technology. For example, now we have the same segmentation all of the new thing. So we want to take advantage of whatever available, so that we can utilize that thing. So we can put everything with this very powerful out there in the LabVIEW application. And I can see that a lot of people now doing the training through using Python, and then with the Python node connect to the LabVIEW to do the machine learning, deep learning, which is like the common way to do that. So that's why I come up with the idea that building the own tool. So the first tool is like from native LabVIEW, so view everything, design the training tool in the LabVIEW natively, so that if we can talk to the LabVIEW to get the performance of that. And then after that, we take advantage of the existing training engine and then integrate with LabVIEW in such a way that we see that everything is not native. And then next one, when we work with the manufacturing, a lot of requirements that's existing application there, they don't want to touch, they don't want to modify the existing system, because some of those they try to outsource. And then how do we add the value in, and which is why the unveil come up. Yeah.
In terms of AI models, so is this does this work on self-learning models or only on the previously defined conditions?
What do you mean?
Like, is the AI model, are they self-learning, or it is only based on the information you have already fed it?
Yeah. So it is for the supervised learning thing. So all of those things we use the transfer learning. So we use existing model have been trained using million data record, and then we specify on the certain application, which is
So one of the interesting things about vision systems and AI is that you actually have to have an expert there to subjectively determine that something that is new, that is coming in, is actually acceptable. And unfortunately, we've found that a little bit problematic in some areas, trusting the people, because sometimes they're under duress to get product out the door, as opposed to do a good job. And this is brilliant stuff. But in the NPI phase, you definitely need your expert. And every time anything changes, you need your expert. And gradually over time, it tapers away. But it's one of those things you just can't back out from. And once you start learning bad things,
it's like a bit of a myth that you can put low-paid, poorly trained people on the training task. But actually, you need to have your highest skilled people doing the training.
Yeah, it's
in the beginning.
In order to utilise the tools very well, you should have some pretty good people in production 24/7, and particularly during NPI, and every time there's a spin or a change or anything like that, because AI can't say, well, listen, I know it's not the same, but I'm going to say this is good. That's
what we done, what we observe is like normally when we collect the data is not always sufficient, because you work with it already know. And then normally we train the first model, right? And then we put it inside the semi-mode. Maybe the first one is the manual mode first, but we quietly see some kind of the defect or something like the result is not correct, and then put on the folder that we can review, and then retrain the model again. And then when it's getting better, then we can tweak in the semi-mode, right? Between the manual and then auto mode. And then when we have the confidence level, which is the product haven't changed, then we switch into the auto mode. Yeah.
With the system you're proposing, how do you unlearn something that was incorrectly learned? So someone said, yes, I think that's great. AI, go for it, I like it. And then, of course, it's not correct. How do you go back in and unpick those, finding the images?
Yeah, that's a good question. That's the reason why when we deploy that thing, always we have some kind of verification phase where we're going through all the results again. Some kind of the, for example, that one is quite obvious, but some of the application cannot be seen with the normal eye, right? So we need to have some kind of the pre-processing in order to find some kind of feature on that, which is quite difficult.
What's the scale we're talking in the sense, can a small business producing low volume but high quality systems use vision AI, or does it need to be high volume?
Yeah, it doesn't need to be high volume. That's the reason why unveil have two different things. So the first one is the unveil itself. When you install on the server, and then on that server, if you have the GPU, then you don't need to have the S device. Then you can run up to 10 cameras, for example, depend on the speed you want. And then you want to scale up, then we add device in. And for the LabVIEW user, they don't want to go through that part. We can do exactly the same. When we see that one, it's only the client of the unveil, so which is the UI. But when we deploy it, it's like the service, it's like the Windows service, it's like stick in on, and then it's doing something like the small process, doing all of the analytic in there, and then talk to the LabVIEW application. So the LabVIEW is like outsource all of the vision in there. And again, that one is not also doing the machine learning, deep learning. We also are doing the computer vision as well. So we have the NI vision development in there. So technically, we can outsource all of the vision to the unveil, and then the LabVIEW only focus on the process.
So you exclude AI and just use it.
Yeah, we can do that. Like I said, we have the plugin, right? So all of the customized plugin can be defined through the pack library, which is good. We'll talk about tomorrow. Vision control, and that's perfectly suitable for that scripting. Yeah. Yeah. Yep. So in here even that's one. You see that the counting, actually we build our own tracker based on the famous by track. If you in that area, we have deep sort a few things, and so it's native in LabVIEW. Yeah.
How many systems have you deployed it to?
So that's to be honest, we talk today is on the manufacturing. Because we are doing the manufacturing, but that one is like we work with the VMS system, so video management. So video management, they don't do customized AI model training like that. So they have video analytics, which is a facial recognition and license plate, which is that's the existing model, and then some kind of the simple thing. Down to that level, they don't have. So now we work with them in order to provide a lot of got the functionality, for example, that the abnormal behavior detection, and some kind of the production recognition in here. So quite a number of things. Yeah. So it's not limited to the manufacturing. It's on retail, on hotel management, on smart transportation. Yeah. You name it.
People that are going to deploy something like this, the speed of the MES, the ping time, the speed to get a response back.
Yep.
I know from my perspective it's been a pain.
I know.
With big manufacturers, they sometimes are tremendously slow.
Yes, so that depends on the network you use. So I work with the food and beverage. They give me 30 frames per second for the surveillance cameras easily. And also we work with a few hardware company. They have some kind of special hardware that's called the S device, and then on the S device have the several type of interface. So have the built-in camera, which is if you see in here that the one of the that's one. That's the built-in camera, bachelor camera on the ARM Cortex with the GPU inside. So you can do the real-time detection in there, or you can on the same company they produce some kind of the S device with the GDevCon interface as well. So we can put the GDevCon camera directly into there instead of use the surveillance camera. Yeah.
Sorry, I'm hogging this. Are you familiar with part average testing, which is the automotive guys are in love with it, and particularly silicon people love it. And I can see an application here. Part average testing basically says if boxes, and I saw these beer boxes, you know, going on the conveyor belts. Well done. And part average testing works like this. This is what I'm seeing. This is what's normal. So I'm going to accept everything that looks normal. But anything that doesn't look like this badge, I'm going to reject it. Even if it looked like a prior badge. Because what's it doing in there? How did it get there? That kind of thing. So part average testing is a very interesting way to detect abnormalities as you're creating batches of things. And it's a very interesting source of material. I've got the standard, and I think it's online, you can download it. Pattern testing, very interesting.
Thank you. Thank you.